Okay, so where I'm going to start is with the 45-degree offsets, like I said. It is from first year now, but just to make sure I cover all my bases, and for those of you who didn't do a common first year, we're going to start here. I'm going to just scroll up to where the objectives are. That's what I want to see. And I have the objectives here. Right here. So we're going to define, some terminology. We're going to calculate simple 45s. We're going to calculate 45s around corners, and we're going to do Pythagorean theorem. Now, I don't particularly like the order that this is in. I am going to do number 4 first, then number 1, 2, 3. So I'm going to start with a little bit of terminology and then Pythagorean theorem with you. Now, before we get right into this, is there any questions that anybody has of me before we start that you want to get through, or if you have a burning desire or whatever it is, if you want to, any questions to date on anything?
Yeah, I was wondering, Doug, if just on the test, I think it'd be beneficial if I could if you could send me the answers I got wrong, just so I don't get them wrong yet. Is that a possibility? Like,
yes and no. So from now on, what I'll do on the test is I will make sure I indicate on there which ones you got wrong. How's that?
that would be awesome. Yeah, like even if the one time, just so if I, we see the question on the final, I don't make the same dumb mistake, right?
I understand. I'm going to do that for the rest of the test assignments on D2L.
Okay, awesome.
I'd like
Thank you.
to see what I got wrong and see if I can figure out how I got it wrong.
Exactly.
And that was for the last assignment, Alex?
Yeah.
Really, all the assignments to date.
I feel like that last assignment, I got like 4 wrong, and I'm just like, I wonder which ones they were. So.
Well, let me do this for you then. What I'll do is I'm going to share here. Let me just see if I can pull this up. I'm going to share something with you. There. Buoyancy. Somebody okay? Did they crash? Sounds like somebody crashed. Let me just share this with you, okay? I'm going to share this with you. Here we go. Okay, can everybody see the assignment 5?
Yes.
Water properties and buoyancy. So what I'm going to do is I'm just going to scroll through this here with you and stop if you have any questions. How's that?
I'm good with that.
All right. Now, a lot of people made a mistake on number 4 here. Remember, between 5 and 6, it's a factor of 10. Between any numbers, it's a factor of 10. So it's 10 times more hydrogen ions between these two.
So then between 4 and 5, there's 10.
Well, between 4 and 5, there's 10 times more hydrogen ions in number 4 than is number 5. Yeah. We're good so far?
Yep.
Just shout out if you want to stop me somewhere.
Sorry, one more time. Can you explain 11 and 12 maybe? Because I keep, maybe I'm reading the question wrong.
Yeah, that's where I think I probably would have got mine wrong too.
Number 11.
Like all those.
Okay, number 11 says an object that floats displaces a volume of liquid less than its own volume. So let me just do that. Hang on a second. Can you see my blank paper there?
Yeah.
Yeah.
So if I had a container of water, right? So an object that floats, okay, I'm going to use my beach ball example. An object that floats when it's in the water, when it's placed in the water and it's floating, it's going to displace this much liquid. That's how much liquid that particular object that's floating is displacing. So an object that floats displaces a volume of liquid less than its own volume. For example, if this volume of this ball was 1 cubic foot, when I put this in the water, it's only going to displace this much water. That's it. So the volume that it displaces is much less than that.
Okay.
Let me go back to that assignment here.
I think that in the ILM,
Uh-huh.
you know, I was trying to read through it and I was going through it and I just can't seem to wrap my head around it because I feel like in the ILM it talks about mass and the questions here are talking about volume.
Yeah.
Yeah, so you were tricky. And
Yeah. That's very tricky. It is designed to get you to think really hard about it. Sometimes drawing out a picture can help. Okay. So, yet again, on your final exam, I think there is, at this point, about 3 questions total on buoyancy and water properties. Well, maybe a couple more on water properties, but on buoyancy itself, you have about 3 questions. Okay, I'm moving on. 12, 13.
Do the same place.
Is that a question, Brandon? Sorry.
Yeah, I was maybe like 15, like an object that displaces a weight of liquid less than its own weight.
Yeah.
I'm not too sure why I can't really get that either.
Sure.
Yeah,
I
it's just
understand.
like, I think it's just the wording that, yeah, it really
That's-
it is messing me up.
I will
Here,
try to explain that here. Hang on a
Yeah,
second.
I feel like those are the answers that I messed up because I was like, how did I?
Okay.
I was up all night thinking about it,
Okay, so
crying in the shower.
I have an object here that is 1 cubic foot, for example. This object weighs 100 pounds, okay?
Yeah.
Concrete block, 1 cubic foot. I don't care what it weighs. So if I put it in water, this object right here, right? So this object sinks to the bottom because
Correct.
it will displace this much liquid, right? And it's only because it's 1 cubic foot, it's only going to displace 62.4 pounds. But the darn thing weighs 100 pounds, so it's going to sink. So for number 15, it says an object that sinks displaces a weight of liquid, which is a mass,
That's
less
less than the
than
actual.
its own weight.
Oh, okay.
Yeah, the wording is really bad. I mean,
Oh, definitely.
it depends. It depends on your opinion. The wording can be really good as well. Depends on where you're sitting. For me, the wording is really good. For you, maybe not so much. Sorry for saying that, but it's kind of true. All right. Next, okay. Actually, a lot of people get number 16 wrong, and I'm not sure why, but why is that hot water circulation by gravity is using buoyancy as a principle? Because warmer water rises and cooler water is more dense and sinks. So drops. Yes. Okay, number 17. Yes,
Doug?
Curtis. Yes.
Can you, like, between B and C?
For number 17?
Yeah.
No. Okay, I'll work it
No,
out.
I mean, elaborate.
I'm going to work it out for you, okay?
Yeah. No, I mean, no, just for the wedding.
No, it says, what will it do when you place it in water? Equilibrium is neither rising nor sinking. It's definitely not floating, and it's not sinking to the bottom. That's what equilibrium is. But this object that we're talking about is barely float, with most of the object submerged. So I want to explain this and how I got to that. So we have an object with a volume of 0.658 cubic feet, and it has a mass of 40 pounds. So I want to get its density. So I'm going to do 40 divided by 0.658. So its density is 60.7 pounds per cubic foot. And if I divide that by 62.4 pounds per cubic foot, I can get its relative density as 0.974. So it is lighter than water. It is going to float, but barely. It's not going to sink, it's going to float, and most of that object would be submerged in the water. Now, when we're talking about these things, it's always fresh water we're talking about. Because fresh water, as we know, is what we deal with, and that's how we can determine all of these numbers. Now, when water is salty, like the Atlantic Ocean, it is one of the saltiest big oceans around, it is more dense. So you actually get more buoyant in those places. Like at places like the Dead Sea, you can lie on top of that water and just float there. You will float because that water is so dense. I think there was a story about a guy walking on water. Wait, I shouldn't bring that into anything. But anyway, the water is so
It was Chris
dense
Angel.
that you float on the water, right? So there you go. More
So at what
mysteries
point?
revealed. Say again.
At what point would you like where you would be more out of the water, where the object would float more? At what?
One would be in equilibrium.
Correct.
Do you want me to describe how this really works, like with a personal flotation device, that sort of thing?
Sure, yeah.
Okay, well, watch this here. I have an explanation. So
That'd be nice.
if I had a person that weighed 150 pounds, okay,
That's what I would.
and their volume was 2 cubic feet, okay? And then, so let's find out what the buoyant force is on that person without any personal flotation device. So if I go 2 times 62.4, the buoyant force pushing up on that person is 128.8 pounds. Now, that person weighs 150 pounds. Will that person sink or float?
Sink.
Sink. Okay, so what I'm going to do is I'm going to put on a 2-pound personal flotation device, a vest that weighs 2 pounds, but guess what? It has a volume of 1 cubic foot. So now that person is 3 cubic feet. So 3 times this is 187 pounds. Now the person weighs 150 pounds and we have a buoyant force pushing up on it of 187 pounds, or 152, I should say, because of the 2 pounds, 152. So was that person going to sink or float now?
He'll float.
Yes, but that person is going to be mostly submerged in the water with their vest on. Okay? So they're going to be mostly submerged. And some of them out because of these differences right here. Does that help?
Okay. Yeah, it does.
Okay. Yeah, that's a good question. Maybe we'll see that later in a text or something. I don't know. Love that question. All right. Number 18, 19, and 20. Let me stop sharing here. We'll go back to that sheet. All right. There's the other 3 questions. Now, for 19, excuse me, 19 and 20, did anybody figure out the shortcuts? And you're saying there's a shortcut?
Yeah.
You got the shortcut, Curtis, for 19?
I think so. I can't remember. 925 minus.
Oh no, I'm talking about 19. 19.
Oh, 19. Sorry.
Okay. Well, let me give you the shortcut for 19. So have a look at 19. Object weighs 320 in air and 280 in water. What is the relative density? Okay. Let me go back to this screen over here. Okay. Oh, I don't want to do that. I will say that this object weighs 320 pounds in air, 280 pounds in water, which means the buoyant force is equal to 40 pounds. Yes?
Yeah.
Okay, so if I take the object's mass and I divide it by the buoyant force, that would equal the relative density. So 320 pounds, that's what the object, that's the mass of the object divided by the buoyant force.
Yeah.
Okay. So that was number 19, and you do number 20 the very same way. Now, I could do a bunch of different things for that. I could find out the volume of the object and then find out the density and then divide by the relative density of water to get the relative density of the object. All right. That was fun, eh?
Good times.
Good times, this mathematics. I love
Making
math.
memories.
I love making memories. I love it. I'm making memories too. I'm killing brain cells right here. I'll tell you that much.
Oh, I saw how fast you did that last calculation.
Yeah.
You still got it.
Yeah. Well, I've done it twice or 3 times. Okay. So now let's get into some Pythagorean theorem here. Let's see what I can do. Okay, so now's the time if you need a pen, a paper, something to take some notes with, now is the time to do so. Oh, not sure what you guys are looking at right now. Are you looking at my blank page?
Yep.
Yeah.
Yep, thank you. Okay. So to start everything off, we always have to be aware that we will be dealing most always with right angle triangles. A right angle triangle is where we have a 90-degree corner. Okay, always. This is what we're going to be dealing with always. Now, I'm going to ask a question. Just shout it out if you know what it is. Does anybody know how many degrees a right angle triangle all added up equals to? If I add up all the degrees of the angles within a right angle triangle, what is the answer?
180.
That's correct. So everything inside here would equal 180 degrees, including that 90. So these two angles make up the other 90 degrees. So in what we need to know, if I had a right angle triangle, I'm going to call this line right here. Now I'm going to highlight, each line has a name. So this line right here on the bottom, and if I'm talking about this angle right here, this line would then be called the side adjacent. It is the side adjacent to this angle. Okay, it's beside the angle. Adjacent means beside. This line next, up here, this line on the triangle is then referred to from across this angle, would be the side opposite. So this line is opposite of this angle. I don't know what this angle is. Just put an X there. So that line is called this side opposite. And now this line would be called the hypotenuse. Okay. Very easy, very quick. So I have the side opposite, I have the hypotenuse, and I have the side adjacent. So that is a little bit of terminology as we move forward. I'm going to take that off there. I'm going to use a new screen here, new page. I have a right angle triangle. 90-degree right angle triangle. And I typically name them A, B, and C. Now, Pythagorean theorem states that A squared plus b squared is equal to c squared. And before I get too far, I want to talk about the the 3-4-5 rule. Does anybody know what the 3-4-5 rule is? Okay, well,
Yep.
I'm gonna tell you. Yeah, you know what it is?
Other side.
I think so.
Go ahead, tell me. I'd love to hear it.
I can't remember. Like the A and B side. 3 and can't remember.
Okay, no worries.
Someone explained it to me.
That would be the C.
Now, I'm going to tell you what the 3-4-5 rule is. I'm going to come back to this, okay? Here we go. Here's the 3-4-5 rule. So if you want to know if you're working with a perfect right angle, if you want to know if you're working with a perfect right angle, you could take any, I don't know if you can see that. Can you see my ruler on there?
Yeah.
Okay. 1, 2, 3. So if you want to know if you're working with a perfect right angle, this is what you do. You measure from the corner outwards 3 inches, 3 feet, 3 meters. I don't care what the measurement is as long as it's 3. And then you go to the other side and you measure out 4. This in this example is 4 inches. It could be 4 feet, 4 meters, as long as they're all the same. And then in between them, if you're working with a perfect right angle, in between them, it should be exactly 5. Does anybody see that?
Oh my God.
So that way, you know you are working with a perfect right angle. See that? Look at that, 3-4-5 rule. This is used widely in the trades with steam fitter pipe fitters as they put together offsets. So this is a way to dealing with a starting point. Okay, that's the 3-4-5 rule. Pretty cool, huh? Well, let's put the 3-4-5 rule to the test. Okay, so I'm going to say, let me rewrite a page here. I'm gonna get a triangle. So if A equals 3 and B equals 4, then C must equal 5, yes? And we'll do the A squared plus B squared equals C squared. So we're gonna go 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 equals 25. Holy crap, look at that. That is proving the 3-4-5 rule. Now this guy Pythagoras, he figured out that he could use the A squared plus B squared equals C squared anytime for any right angle triangle to solve for one unknown. So first off, let's start with some examples. I have a triangle, right angle triangle, A, B, C. I'm going to say that A equals 15 and B equals 32. What is C? So at this point, I'd like you to get out your calculators and get ready to start to do some calculations. So we are going to go 15 squared is equal, or excuse me, plus 32 squared is equal to C squared. That's how the formula breaks down for us. So the formula, remember, was A squared plus B squared equal to C squared. We're using Pythagorean theorem right now to try to solve for C. If you did not know this, there's a square button on your calculator right here, along with the square root button when you go shift square root. So I'm going to go 15 squared, which is 225. And I'm going to go 32 squared, which equals 1024. So that equal to 1, 2, 4, 9. So C squared is equal to 1, 2, 4, 9. Can everybody see that so far?
Yeah.
Now, I wanted to get C. This is what I want. I want C. So I have to square root C squared to get C. If I do it to this side, I will square root 1249. So I hit the shift button and the square root button. So C equals 35.34. Good.
Cool.
Cool. All right. I'd say we should do another one, yes?
Yes.
For sure. We're going to do a bunch more. Then I'll get you to do some. Okay. New sheet. Right angle triangle. A, B, C. Now, part of our job is also to be able to manipulate the formula. Now, I'm going to be able to tell you how to solve for different letters. So if I go C squared minus B squared, that's going to equal A squared. And then C squared minus A squared is equal to B squared. So I would recommend you write those formulas down. That's how to solve for C, A, and B. These formulas right here, you need.
Rearranging the formula, right?
Yeah, I'm just rewriting the formula so I can solve for these individual ones. So if I needed C, this is how I do it. If I needed A, this is how I do it. If I needed B, this is how I do it. I'll give you a second to write those formulas down so you have them. Okay, here's the example. Take a minute, solve for B. You're typing in your last letters. I'm going to go 145 squared minus 72 squared is equal to B squared. everybody concur with that, which is on the paper?
Concur.
Concur.
Yep.
Concur. Awesome.
Yep.
So I think this is not too hard now. So let me just see here. Dun, 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 dun. Okay, I threw a file up there for you guys. Did you see? Does everybody got the file? What I'm going to do is, this is a worksheet, and I'm going to put you into some groups, some breakout rooms, and you guys will have to work on that worksheet, and you have till 1 o'clock. And then at 1 o'clock, I will come back online and we'll mark this sheet. So grab that sheet, everybody, and I'm going to put you into some groups here. Okay, here you go. Oh, what did I do there? I did something wrong. There we go. Options. Okay. This is fun. Okay, here we go. I'm going to start sharing my screen again. And can everybody see, what do you see? See my blank paper? Yeah, okay, good. So, we know Pythagorean theorem and what that is. In the pipe trades, in our pipe trades, we have different names for these lines on a triangle. And you also need to know this terminology. So let me just redraw that. This line right here, if I'm talking about this angle, that line is called the run. So in our pipe trades industry, we call that the run on the triangle. We call this line here, we call that one, we call it the offset. Sometimes we call it the rise. Sometimes we call it the set. So a bunch of different names or terminology for that particular part of the triangle. And then of course, this line here, we call this the travel. So we have our terminology as we talk about this in the pipe trades. So I'm going to make a statement here. if I had a right angle triangle and this angle was 45 degrees, let me see that. 45-degree right angle triangle, that means this angle also has to be 45 degrees. Yes?
Yep.
Yes. So in a 45-degree right angle triangle, I'm going to write this out. In a 45-degree right angle triangle, the run and offset are the same. In a 45-degree right angle triangle, the run and the rise are always the same length. And I should write that, the same length. Always the same length. In a 45-degree right angle triangle, the run and the offset are the same length. Okay. I hold that for a second. Just want to make sure you got, if you're writing it down, I just want to make sure you write it down. 45-degree right angle triangle, run and offset, or rise and run, are always the same. Now, in a 45-degree right angle triangle, if the run and rise are the same, so if A and B are the same, then C would have to equal something, and we could determine this. So if I said A was 1, and if I said B has to be the same in a 45-degree right angle triangle, then what is C? So I'm going to go 1 squared plus 1 squared is equal to C squared. So 1 squared is 1, 1 squared is 1, is C squared. So 2 is equal to C squared. And then the square root, C equals 1.414. So I have determined in a right angle triangle, 45-degree right angle triangle, the travel is always 1.414 times longer than rise or run. In a 45-degree right angle triangle, the rise and run are always equal, and the travel is always 1.414 times longer than the rise or the run. And we used Pythagorean theorem to kind of prove that theory. Now this is the start or the beginning of how to solve for offset pipe arrangements. And that's really where we're going with this. We need just the terminology, we need the basics of the theory of how they come up with some of these numbers to then implement in to try to figure out offsets. And for the time being, we're only going to do 45-degree offsets for now, just for now. But that will change. We're going to do all kinds of weird things later on. But for now, we're just doing 45-degree right angle triangles to calculate offsets. So let's do a couple of problems, or examples with a 45-degree right angle triangle. So if I had a triangle, a 45-degree right angle triangle, and I told you A, B, C, A equals 10, what is B? What is C?
So can I just take 10 and times it by 1.414?
You get C? Yeah.
No, yeah, yeah.
Because I told you that A and B
They're going to be 10.
are always the same.
Yeah.
And C is 1.414 times longer. The travel is always 1.414 times longer. So you're right, Sylvie. That's exactly correct.
So that's the cheat. Like that's the easy way of finding it out.
This is the cheat, I guess. But this number, this 1.414 number, is used by steam fitter pipe fitters around the world. It's so typical of these triangles. And it doesn't matter if it's in meters or whatever, meters, centimeters, inches, feet. It's always 1.414 times longer for a 45-degree right angle triangle. Okay. So let's do another example of that. I have a 45-degree right angle triangle, A, B, C. So rise, run, offset, B is the run, C is the travel. So A, sorry, is the offset or the rise, B is the run, C is the travel. So if I told you C is equal to 32, what is A and what is B?
So you take 32 and you divide it by 1.414
You are so smart.
just today.
That is exactly correct.
Okay.
So if I go 32 divided by 1.414, that equals 22.63. And they're both the same. A and B are always the same on a 45-degree right angle triangle. The rise and the run are always the same. Cool, we're getting there, huh? Not too bad. Okay. So now I'm going to give you another worksheet. Yay. So let me get to my next worksheet. Oops. Oh, there we go. Okay, can everybody see that in the chat? I sent a new document in there. And we're gonna go back into our breakout rooms. Now, this is very clear, leave it in decimal form, okay? Leave everything in a decimal form, and that's fine. And I'm going to put you in, I am going to open all your rooms again, and I'm gonna give you 20 minutes. So 1:35, I'm gonna call you back in.